Hello everyone, this is Miss Martinez. We are going to be looking at the first need to know of Unit 7 today, and that is, what is a binomial? And so in order to do this, we first need to know what a polynomial is, and that is like kind of the big category that a binomial is under. So here's our term polynomial. It's kind of a mouthful. So it comes from two different words. We've got poly, which means many. And then we have nomial. Kind of comes from the word name, and that means a term. Okay, so polynomials have many terms, and so we'll talk about what that means throughout this video. So it's got to be an expression. So any mathematical expression that consists of variables. So any letters representing numbers, coefficients, that involves only the operations of addition, subtraction, multiplication, and then non-negative integer exponents. Okay, so if there's an exponent on a variable, it cannot be negative, and it must be a whole number. Okay, so let's look at some examples of some expressions, and we're going to kind of break them up into some vocab that you're going to hear a lot with polynomials, and that is terms and coefficients. Okay, so our first expression is 5x plus 8. So this expression has two different terms. A term is basically like, where do the different numbers separate? Okay, so 5x is a term. So we've got two terms, and they consist of 5x. 5x represents one number, so it's its own term. And then 8 is the other term. That's a different number. So those are the only two terms in that expression. So the next one, we have 2m cubed. That's to the third power, or you might also hear that as cubed. That's all one number. 2 times m cubed, that's one term together. So this is only one term of 2m cubed. Okay, terms are separated by addition and subtraction. Multiplication does not separate terms. That actually keeps the term together. So on the next one, we have x squared minus 4x. I've got that subtraction in the middle there, so I know I have two separate numbers. So two separate terms. We've got x squared. That's one number. And then the other term is negative 4x. Remember, the sign in front of the number goes with that number. So that minus there, since it's in front of the 4x, makes that a negative 4x. Okay, and then we've got negative 3w to the fourth power plus w squared minus 9. So I see three separate numbers that are separated by two different operations. So I've got three terms. First, it's the negative 3w to the fourth power. That's all together. Then we've got w squared. And then we have negative 9. Okay, so that's how we break up a polynomial expression into the amount of terms that it has. Now let's look at coefficients. So remember, coefficients, that's the number that's in front of a variable. Remember that co means with. So it's a number with a variable. We can put that up here, in front of variable. Okay, so on 5x plus 8, the only term that has a variable in it is 5x. So the coefficient is the number in front of the x, so that is 5. Okay, on 2m cubed, the 2 is the coefficient. Basically, it tells you how many of the variable you're going to multiply by. Okay, on x squared minus 4x, we have 2 different terms and they both have variables. So we need to take the number in front of both of those variables. So there's going to be 2 coefficients. X squared has a number in front of it. It just doesn't look like it right now, but it has a coefficient of 1. So 1 would be 1 coefficient. And then negative 4 is in front of the x. So that's also another coefficient in that expression. Negative 3w to the 4th power plus w squared minus 9. We have 3 terms, but only 2 of them have variables. So we're only going to have 2 coefficients. Negative 3 is the first one in front of the w to the 4th power. And then in front of w squared, again, there's no number there, but we know that it's being multiplied 1 time, so our coefficient is 1. Okay, so that's how you break up an expression into its number of terms and its coefficients. Now let's look at determining if an expression is a polynomial or not and why. Okay, so before we had said that a polynomial has to have variables and coefficients. The only operations in it can be addition, subtraction, and multiplication. And if there's an exponent, it cannot be negative, and it must be a whole number. So we're going to use those into consideration when we decide if something is a polynomial or not. 9 plus 12x, that has 2 terms. We've got addition, I see variables, so this is good to go. This is a polynomial. Okay, next we have 6m to the 1/2 power. So we've got an exponent here, but it is not an integer. 1/2 is not a whole number. So that does not meet our test. This is not a polynomial. And our reasoning is because we have a fraction exponent. Okay, next we have 3 divided by x minus 8x. Now notice, division was not an operation that a polynomial can have, and that 3 is being divided by x. And that variable in the denominator actually is another way to write an exponent, a negative exponent. So this is not a polynomial. So I'm putting as the reasoning why is that we've got a variable in the denominator. Okay, and then lastly, we've got negative 2w cubed plus w squared minus 5. Okay, I see addition and subtraction. I see exponents that are integers. I see multiplication. So this one is also a good example of a polynomial. Okay, so here's where we kind of get into where the whole root of our need to know is that we actually have different types of polynomials. We kind of break them down into 3 more categories based on the amount of terms they have. And so in this next table, we're going to talk about how to distinguish them as a monomial, binomial, or trinomial. Oops. Okay, so monomial, we've got that mono in the front here, which means 1. So that means it's a polynomial that only has 1 term. So we distinguish these based on the amount of terms that they have. So then next is binomial. So that word starts with the prefix bi, which means 2. Okay, and then trinomial, that starts with the prefix tri, which of course means 3. Okay, so let's classify these based off of the number of terms that they have. So first, we have 8x plus 3. Well, we've got 2 terms there, so this is a binomial, which is what is referenced in your entry doc. Okay, next we have negative 12. That is 1 number, 1 term, so that's an example of a monomial. Okay, next we have 7x plus 12x squared. That's 2 different terms. They're only separated by 1 addition sign, so that is another binomial. Looks a little bit different than the binomial from before, but that's okay. What makes them a binomial is that they're only 2 terms. They can have different types of terms, but the fact that they only have 2 makes them a binomial. Okay, next we have negative 9n to the 4th power plus 6n squared minus 1. So we have 3 terms here, which makes this a trinomial. Okay, and then lastly we have 5m squared. That is 1 term, so this is a monomial. Okay, so now that we know what a polynomial is and we know all of its different parts, now we can actually do some operations with them. We're going to need to know how to add, subtract, and multiply these. So we're going to start with addition and subtraction. Okay, so when you're adding and subtracting polynomials, the biggest thing that you're going to do is combine like terms. So we know what terms are. They're those separate numbers. But like terms, they have to have the same variable. Okay, so let's look at the first one. We're going to do 5x minus 8 plus 7x plus 10. Okay, so we need to figure out which terms are alike. So that's going to be the x terms. So the ones that are being multiplied by x. And then the constants, the numbers that are just by itself. And we're going to combine them using the operations that it tells us to do. So we're going to take 5x, we're adding in the middle there 7x. So that's going to give me 12x. Here, we can rewrite it like this so you can see what we're adding together. So then let's take our constants. We're going to do negative 8. Don't forget that negative. And then plus that 10. That's a positive 10. So now we kind of have our terms grouped together, and it might be easier for us to combine them. So 5x plus 7x is going to give me 12x. Then I'm going to do my constants. Negative 8 plus 10 is going to give me positive 2. And then that is my fully simplified answer. I cannot simplify this anymore because 12x and 2x are not like terms. Okay, let's do the next one. We've got negative a squared plus 2a minus 8. That's a trinomial. And then we're going to add another trinomial to it. So let's kind of distinguish these like terms here. I've got 3 different terms. I've got a squared, which is different than a. So I've got a negative a squared here, and then I've got a 2a squared over here. So those are like terms that I'm going to add together. Then I've got the a terms. So this positive 2a here. And then this negative 9a here. And yes, we are adding in the middle, but that's a negative 9. So adding a negative 9 is subtracting. Okay, and then finally our constants, negative 8 plus 15. Okay, and so then you just combine the alike ones. We've got negative a squared plus 2a squared. That is going to give me a positive 1a squared. Then I've got 2a minus 9a. That's going to be negative 7a. And then negative 8 plus 15 is going to give me positive 7. Okay, next one. Okay, I'm subtracting 2 binomials here. And I see I've got m squareds that are alike. I've got one m term with this 9m here. and then I have one constant. Okay, so we can do the 4m squared minus the 2m squared since we're subtracting. Then I've got the 9m all by itself. And then I'm going to subtract that 6 because of this subtraction in the center here. This does go with that 6 there, so I'm going to subtract a positive 6. Okay, so 4m squared minus 2m squared is 2m squared. Then plus that 9m and minus the 6. And that's fully simplified. That answer is a trinomial. We have 3 separate terms there. Okay, next we are subtracting 2 trinomials. I see a lot of different terms here. We've got this x to the 4th, and I don't see any other x to the 4th. So that's the only one with that. I do see a 6x to the 5th over here, and I don't see another one. I'm going to put that one first. We typically do the highest exponent first, and we go in descending order. So actually that's going to be a negative 6x to the 5th because of that minus that goes with it there. Then I'm going to add that 3x to the 4th power that we have. Next I see a negative 9x to the 3rd, and I don't see any other x to the 3rd powers. So we're going to subtract that next. Then I see this 3x squared. And then finally, I have 2 constants left. I've got this negative 3, and then this positive 2 there. Oh, but remember, we're subtracting, so this negative sign does go to both of these. So that's going to change the sign on our 9x cubed. Minusing a negative number is going to turn this to an addition sign. Okay, and then this positive 2 at the end is going to create this as a negative 2. Oh, I need my negative 3 first from the other side. Negative 3 minus 2. Okay, so the only things that we're really combining are these 2 here. We're just going to rewrite the rest of it. Negative 6x to the 5th plus 3x to the 4th plus 9x cubed plus 3x squared, and then negative 3 minus 2 is negative 5. And that's our final answer because all of those terms are different. We cannot combine them. Okay, so now that we're done with addition and subtraction, let's do multiplication. So multiplication is going to be similar. It's obviously just going to require some multiplication first. So you're going to simplify your expression by using the distributive property, and then once you've done that, combine any like terms that you have. Okay, so let's look at the first one. I've got 2x times x plus 6. So I've got a monomial times a binomial. this is going to require the distributive property. This 2x needs to be multiplied by the x and by the 6. 2x times x is going to give me 2x squared. Because I'm doing x times x, when you multiply something by itself, it becomes squared. Then 2x times 6 is 12x. Multiply those coefficients. And then that is our final answer. Okay, the second example is very similar. We're multiplying a monomial times a trinomial this time. So you're still going to distribute, you're just going to distribute to 3 terms. So this is going to be 3x times x squared. So I'm going to write out all the x's for you so you can see how this is going to change the exponent that we have. So this is going to be basically 3 times x for that 3x, and then multiplied by x squared, which is x times x. Okay, then we're going to do 3x times the 5x. So do your coefficients. That's going to be plus 15. And then times x times x. And then I've got 3x times that negative 1 at the end, which is just going to be minus 3x. Okay. So you don't have to do this every time, you'll get used to it, but I want you to see how multiplying x's that have different exponents is going to change your answer. So for the first one, I have 3 times x times x times x. X is being multiplied 3 times, so this is going to be 3 times x to the 3rd power. Your exponent tells you how many times you're multiplying x by. Plus 15, and then we're multiplying x twice, x times x, so that's going to be 15x squared. And then minus the 3x. And all those terms are different, so this is as simplified as we can go. Our answer becomes a trinomial. Okay, and then the last two are kind of similar again. 4x squared times x. So that's going to be 4 times x for the 4x squared times that other x that we just distributed to. Then 4x squared plus 2. 4 times 2 is 8, and then keep that x squared. Or, sorry, that means x times x. So then our final answer will be 4x cubed, because x is being multiplied 3 times, plus 8x squared, since x is multiplied twice. Okay, and then our last one here, 9x times 3x squared, so I need to multiply those coefficients. 9 times 3 is 27, and there's an x, and then from the x squared, there's 2 more x's. Then 9x times negative 4x, that's going to give me a negative answer. 9 times negative 4 is negative 36 times x. And then 9x times 2 is 18x. Okay, so this is going to give me 27x cubed minus 36x squared plus 18x. Okay, and so that is how you add, subtract, and multiply polynomials.